Welcome back. So let's talk about data abstraction. Database systems are usually made using complex data structures and processes. These complex constructs describe the data in a database. Now, not all of these complexities can be exposed to the various types of users of a database. A database is usually being used by a certain type of user. So you have a consumer, a person, let's say, who has no technical experience or is not adept programmatically. Then there is a database administrator, and of course then there's the developer or the programmer of the database. So you can classify each user of the database in these three broad categories. Now, not all of these users can be shown the same level of complexity of a database. Not all of them can be showed the complex data structures and processes that go behind the actual use or the creation of database system. So these complexities are abstracted and presented in three levels depending on the user. There's a typo here, so it's levels, three levels. The first level or the highest level of abstraction is view level. The lowest level of abstraction is physical level, and then there's a level of abstraction that sits between the two, which is logical level. Now, what is view level? All right. So this level, it describes only a part of the entire database. It provides a very simplified manner in which a user can interact with the database system. So it provides many views. Now, by views, what I mean here is there are various formats, you could say, in which the user can access the database. Then there comes, this is purely for a person that just wants to use the database or has no programming knowledge, you could say. All right. So moving on, then there's the logical view of the database. Now, this level of abstraction describes what data is stored in the database, the relationship between the data. This abstraction level is typically used by database administrators. Then there is the physical level. This is the lowest level, lowest abstraction level. It describes how is the data actually stored. It actually describes the database in itself. So it describes in detail the complex structures used to store the data. And this is typically what is used by programmers, and it is exposed only to programmers. So moving on, some more terminology. So when we talk about database, you'll often hear the term schema. So schema is nothing but the overall design structure of a database. So it's data structures used to store the data and so on and so forth. Data independence. This is a term that's used to describe the property of the database management system that allows changes of the schema at any level of the database without changing other level schema. So if I were to change the schema at the logical level, it would not affect the schema at the physical level. So that is what is meant by data independence. Moving on, instance of a database. So when we talk instance or snapshot, so these two words are used interchangeably. So what this means is it is a collection of information stored in the database at any particular moment. So since a database constantly changes, somebody is reading a database, somebody is writing to it, data is being deleted, so on and so forth, updated. So at any particular moment, right, some time t, the collection of information that is stored in the database is the instance of a database. Now let's talk about database architecture. Database management systems have three types of architecture that are classified into tier 1, tier 2, and tier 3. So the tier 1 architecture is also known as the central architecture. So what in this sort of architecture, the client, that is, you could say, the user, the application server that sits in between, and the database system. So the server, it usually sits in between the client and the database system. So all these three components, that is the client, application server, and database system, all of those reside on one central computer, on one computer. So this is typically what is used when we are practicing database systems. So let's say we've downloaded MySQL, MariaDB. So in such a system, the client is also on our system, what the GUI or whatever we're using to interact with the database, the actual database system, and the application server. All these three components are on our system. Now, tier two, in tier two architecture, there is just a client and a database system. There is no application server. And the client and the database system, both of these reside on two different systems. So there can be multiple clients communicating with one single database system. So just assume the database system is on some server, all right, and there are multiple clients, client A, client B, client C. All of these are on three different systems. All of them can establish a direct communication with the database system. So the advantage of such a database system is that, first of all, there is a clear differentiation between the two systems, that is where the client is and where the database system is. Second, there is an extremely fast communication between the client and database, because there is no middle layer, the application server in between the two. Moving on, tier 3 architecture. So it is much like tier 2, but here is where an application server sits in between the client and database. This is usually what's used in web applications. So what happens here is that the client, all right, so the client, let's say the front end of a website, all right, so you fill some stuff in login. This data goes to an application server. It does not directly go to a database system. So let's take an example of a login page. So I log into this user page, I log into this website, and when I enter the credentials, so the credentials will first be validated. It will be checked whether some sort of malicious data is sent. Is this data actually true? Is this adhering to some password criteria, so on and so forth. The data will be processed, and then it will be sent to the database system. So the client does not directly communicate to the database system, it communicates with the application server, and then the database system will communicate with the application server. And the application server will send the response back to the client. So this allows a layer of security in between. That is an advantage of tier 3 architecture. It provides security. Server system architectures. So server systems fall under two categories: transaction and data servers. Transaction servers, also known as query servers. These servers handle requests from the client to perform an action, in response to which they execute the action and send back the results. The servers, that is. Requests may be specified using SQL or some other API. Then there are data servers. These servers handle requests from the client to manage individual files, records on the database, allow managing the data on the database.